This is assignment number 6. Calculate the amount of barium. Let me write equation first. Barium chloride and sulfuric acid. Gives barium sulfate and 2HCl. Calculate the amount of barium chloride required to react completely with 4.9 grams of sulfuric acid. Also calculate the number of moles of HCl produced. Atomic weights are given. Now, starting moles, we are given 4.9 grams divided by molecular weight. This will come out to 0.05 mole, right? And for 0.05 mole, we have to calculate how much barium chloride is required, how many moles of HCl will be produced. Now, number of moles required and produced. For 1, we need 1. It means we need 0.05 mole of this HCl. 1 will produce 2 moles, 0.05 will produce 0.01 mole. So this is one answer. Number of moles of HCl produced 0.01 and weight of barium chloride required will be 0.05 into molecular weight of barium chloride is 208.5. So many grams of barium chloride will be required. Second numerical. 4.45 cc benzene, density and molecular weight is given, was burnt in excess of oxygen. Calculate the mass of water produced and volume of oxygen at STP required. Now, first we calculate benzene. Benzene is 4.45 cc multiplied by density 0.877, so many grams. Now, if we divide this mass will come out to 3.9 grams. If we divide this mass by molecular weight, that will give us number of moles. So number of moles of benzene will be 3.9 divided by molecular weight 78. This is 0.05 mole. Right? So, wait a minute. So 0.05 mole of benzene we have started with. Now I'll write equation. Benzene plus 15 by 2 O2 gives 6 carbon dioxide and 3 water. Starting moles. Benzene is 0.05. We have to calculate mass of water produced and volume of oxygen at STP required. Number of moles required and produced. We want to calculate number of moles of volume of oxygen required. See, for 1 mole, 7.5 moles of oxygen is required. So 0.05, how much will be required? 0.05 into 15 by 2. So many moles of oxygen will be required. Later we convert into volume. Similarly, for 1, 3 moles of water will be produced. For 0.05 into 3. So many moles of water will be produced. Now we come to final answers. Volume of oxygen required will be number of moles into 22.4, because 1 mole of any gas at STP will occupy 22.4 liters of volume. So many liters of oxygen is required. This is one answer. Weight of water produced will be 0.15 mole into molecular weight of water 18. So many grams of water will be produced. This is second answer. Third numerical. air contains 21% oxygen by volume. Calculate the volume of air at STP required to burn 1 kilogram of sulfur to sulfur dioxide. Sulfur contains 4% incombustible matter. It means pure sulfur is 96%. 96% of 1 kilogram will be 960 grams. 960 grams will be 960 divided by atomic weight, 30 moles. Right? So 1 kilogram of impure sulfur contains 30 moles of pure sulfur. Now I'm writing equation. Sulfur plus oxygen gives sulfur dioxide. Now, for 30 moles of sulfur, naturally 30 moles of oxygen will be required. It means volume of oxygen required will be 30 moles into 1 mole will be 22.4 liters. So this will come out to 672 liters of pure oxygen. Pure. But we do not have pure oxygen. We contain oxygen in the form of air, and air contains 21% oxygen by volume. And our question is, we have to calculate the volume of air required. Now, what is the meaning of 21% air, 21% oxygen in air? It means if we take 100 liters of air, it will contain 21 liters of oxygen. Or we can say for 21 liters of oxygen, we'll have to take 100 liters of air. For 672 liters of oxygen, how much air do we need? That will be our answer. So volume of air required will be 100 divided by 21 into 672. So many liters of air will be required. That will be the answer.
Yes, sir.
Any doubt?
No, sir, no. Okay.
Fourth numerical. Calculate the cost of complete neutralization of 1 kilogram of sodium hydroxide with 80% sulfuric acid, which costs rupees 4 per kilogram. NaOH plus sulfuric acid gives sodium sulfate plus 2 water. Now we have 1 kilogram of sodium hydroxide. See, this is 2 into molecular weight 80, and this is molecular weight 98. It means for 80 grams of NaOH, sulfuric acid required is 98. For 1 kilogram, how much we need, that we can calculate. So weight of sulfuric acid required, for 80 we need 98. For 1 we need 98 divided by 80. For 1 kilogram we need this much. When we calculate, this will come out to 1225 grams. But remember, this is the pure amount, pure mass of sulfuric acid required. But we do not have pure sulfuric acid, we have 80% solution. It means 100 grams of this solution contains 80 grams of sulfuric acid, remaining 20 grams is water. It means I can say for 80 grams of sulfuric acid, I'll have to take 100 grams of solution. For this much, how much solution do I need? That I'll calculate. So weight of 80% sulfuric acid required. For 80, I need 100. For 1, I need 100 by 80. For 1225, I need, this will come out to 1531.25 grams. This is nothing but 1.531 kilogram. Now coming to cost. This sample of sulfuric acid costs rupees 4 per kilogram. It means we have to pay 4 rupees for 1 kilogram. For 1.531, how much we have to pay? That will be the answer. The cost will be 4 into 1.531, so many rupees. This will be the answer. Approximately 6 rupees, right? Numerical number 5. Let me write there are two equations. Two KClO3 gives 2 KCl plus 3 O2. 2 CO plus O2 gives 2 CO2. Now, calculate the mass of KClO3, which on heating would produce sufficient oxygen required to burn 84 liters of CO, carbon monoxide, at STP. Now, volume of oxygen required in reaction 2. This you can calculate on the basis of Gay-Lussac's law. Ratio of volume 1:2. For 2 liters, I need 1 liter of oxygen, and I have 84 liters of carbon monoxide. For 84, naturally, I need 42 liters of oxygen. So this will be 1/2 into 84. 42 liters of oxygen is required. This oxygen will come from equation 1. Now look at equation 1. For 3 liters of oxygen, I need 2 moles of KClO3. For 3 liters, for 3 into 22.4 liters, I'll repeat, 3 moles will be 3 into 22.4 liters. So for 3 into 22.4 liters, I need 2 moles of KClO3. For this much, how much I need? Now we can directly use 2 moles of KClO3 as 2 into molecular weight. So I'll write for 3 into 22.4 liters oxygen, KClO3 required is equal to 2 into molecular weight. That is 245 grams. For 42 liters, how much KClO3 is required? That will be your answer. This is the answer. Now, last numerical. 2 zinc plus oxygen gives 2 zinc oxide. This is the equation. (262 grams of zinc gave 241.24 grams of zinc oxide on ignition. Calculate the percentage yield of the reaction. Now, what is the meaning of percentage yield? Percentage yield means amount actually obtained divided by amount we should obtain on the basis of equation, that is expected weight, multiplied by 100. That is called percentage yield. Now, this is 2 into 65.5, and this will be 2 into molecular weight will be 65, 81.5. It means I can say 2 into 65.5 grams zinc should give zinc oxide equal to 2 into 81.5 grams. I've written should give this much. It means 262 grams should give how much? When you calculate this, it's unitary method, you can calculate. When you calculate, this will come out to 326. It means 326 grams of zinc oxide should be produced, but we are getting less than that. We are getting only 241.724 grams. So percentage yield percent is equal to actually obtained 241.24 divided by how much should we obtain into 100. This is called percentage yield. Coming to theoretical questions, give examples of any two compounds which have the same percentage composition. See, you can think of any two compounds which have the same molecular formula or which have the same empirical formula. Or I'll give you an example. You think of an alkene, let us say C2H4. This is ethene, and double of this will be C4H8. This is ethene, this is butene. Both have the same percentage composition, right? Because empirical formula is same. Second question, give any four information conveyed by chemical equation with the help of a suitable example. This you'll find in notes also, where I told you a chemical equation tells us what are the reactants consumed and products formed. Number two, it tells about number of moles of various reactants consumed, number of moles of various products formed. Number three, it tells us what is the weight of different reactants consumed, weight of different products formed. Last, it also tells us about what are the volumes of gaseous reactants consumed, volumes of gaseous reactants or gaseous products formed. These are four information conveyed by a balanced chemical equation. Then the last question to be discussed is predict the value of volume of carbon dioxide produced and oxygen consumed when 10 liters of ethane is burned. Now for this we need equation. Ethane C2H6 plus 7/2 O2 gives 2 CO2 plus 3 water. Except water, rest every reactant and product is gaseous. We are given this is 10 liters. First part of the question is what is the volume of oxygen required? This is 1, this is 3.5. It means volume of oxygen required will be 3.5 times volume of ethane. So 3.5 times of 10 will be 35 liters of oxygen will be required. That is one answer. Coming to volume of carbon dioxide produced. Again, according to Gay-Lussac's law, 1 liter will produce 2 liters, 10 will produce 20 liters of carbon dioxide. So that was about the assignment.